Hello guys, in previous sessions we have discussed the other operations in circular linker list. Now in this session we will be learning about the deletion operation in circular linker list. After taking this session you will be able to explain the deletion operations in circular linker list and you will be able to create and remove an element from the circular linker list. Wait, the deletion operation can be performed in circular linker list in three ways. You can remove the first element, you can remove the last element, and also you can remove any given element. Let's discuss each operation in detail. Deleting the first node. Let us take this as an example where circular linker list having 4 nodes. The first node we are referring with the head node and the last node we are referring with the last. Now here we are trying to remove an element which is referred by the name head, that is the first node. Now before removing that head node, you need to move that head. You need to store the information of head into the temporary variable and move head to the next node. But otherwise, if you straight away remove the head node, it is not possible to track the list later. Hence, you need to store the information of the head into the temporary variable and move head to next node. Now, previously, the last node is storing the address of the first node, that is 4000. So, the last node next to field storing the address of head, that is 4000. Now, head is moved to 1000 now. So, in this situation, you need to change the address field of the last node to 1000 because the head is now referring to 1000 location. Hence, in the reference field of last node, you need to store the address of the head, that is 1000. Then a link will establish between the last node and the new head node. Now here you can remove the temporary pointer by invoking free. Free of temp will deallocate memory for this temporary pointer and this will remove the node from the list. Let's see the function over here. Starting from the head node, store the head information in temp, move head to the next node, adjust the links between the last and the head, and then remove the first node. Let's see the deletion operation for the last node. Again, consider the same circular linker list which is having 3 nodes. The 4 nodes, the first node is pointed by the head and the last node referring with the name last. Now try to remove this last node. Where here first you need to identify the last before node before removing this last node. So this kind of the search you need to perform from the beginning. So the first node is the head node, so that I am making as the temporary node. As this is not the last, then I'll move temp to the next node and I'll store the temp information into the previous. As this is now temp is pointing to 1000, this is not the last node. So what I'll do is I'll move temp to next node and this information I'll store in previous. Now this the temp, this is not the last node, and so what I'll do is I'll move temp to next node and this information I'm storing in previous. Now temp is pointing to the last node, that means the temp is the last node. Now here what you should do is you need to move last to its previous node. So by doing last equal to previous, now the last becomes previous now. Yes, now adjust the pointers between this last and the first node simply by storing the address of the first node in the next part of the last. So in place of 3000, you should store 4000. Then here this will connect the last node with the first node. Now you can remove the last node as free of temp. Let's see the function here. Just take the first node till you reach end of the list. Store temp into previous and move temp to next node. Now here the previous arrow next equal to head. So instead of previous arrow, you can take it as the last. Free of temp. So this will deallocate memory for the last node. Now coming to Now, which is very similar to deletion operation in single linked list. Here again we are taking the 4 nodes. In this node we are in this list we are trying to remove the element, remove the node with the data value 30. Now make a search to locate the element 30. So for that you need to take the help of 2 pointers, the temp and previous. So the temp initially it is referring to the first node. As the temp data is not equal to 30, you are moving temp to the next node and storing this temp information into previous. Now here, now temp is pointing to 2000 location. Temp arrow data is not equal to 30. So store temp information into previous and move temp to next node. Now temp arrow data equal to 30. Now here you stop searching for the key element. Now identify the names for each node. This is temp, whereas this is temp arrow next. And this is previous, this is temp arrow temp, and this is temp arrow next. Just give links between previous and temp arrow next. Just simply temp arrow next equal to previous arrow next equal to temp arrow next. Now you can permanently remove this temporary pointer by invoking free of temp. See the function over here, starting from the head node till you reach end of the list. Try to search for the key value. If not, store the temporary information in previous pointer and then move temp to next node. Just to give the links between the previous node and temp next node. So this will isolate the temporary node. Hence, we can easily remove the temporary node by invoking free of temp. So this is the deletion operation in circular linked list. Let's see the implementation in C. Here we will be using the previous code. Just include function declarations for deletion operation. Void del begin and then void del end. Printf. Deleting first element and then deleting last element. Include function calls del begin and then del end. Take the choice till 7th option. Just implement these two functions. Void del begin. Here store the first node into temp and then move head to next node, head equal to head arrow next. Now adjust the last pointer, last arrow next equal to head. And then you can remove temp. Next, void del end. Here, temp equal to head. Now, while temp not equal to last, you are moving the temporary pointer, previous equal to temp and temp equal to temp arrow next. Now, after reaching to the last node, here what we are doing is last equal to previous If you want, you make last as a previous, or otherwise previous arrow next equal to head. So here I am doing last arrow next equal to head. First, create the circular linker list by taking the choice 1, insert 4 data values. Now let's see the contents of circular linker list. Now the circular linker list is having 4 elements, 10, 20, 30 and 40. Let's see the output for deletion operation. Enter choice as 6, which removes the first element. See the output. Yes, the first element is 10, which is removed from the list, from the above list. And this is the output where which the list is remaining with 3 elements after removing the first element, that is 20, 30 and 40. Now give the choice as a 7, which removes the last element. Now see the output. Yes, the last element got removed from the previous list. The previous list is 20, 30, 40. Now it is remaining with only 2 elements after removing the last element 40. This is an implementation of deletion operation in circularly linked list.